Chapter 1, Lesson 4, Squares and Square Roots. Vocabulary. A square of a number is when you multiply it by itself. It originates from finding the area of a square. It will always be annotated with this exponent of 2. This variable x could mean any number. That 2 tells you you're multiplying something by itself 2 times. So in this case, x times x. Square root is the opposite of squaring a number. A square root of a number is the number that can be multiplied by itself to get to that number. So if given the area of a square, it is finding the side lengths. This is the symbol that tells you you're finding square root of a number. It can also look like this. To find the square of a number, you're simply going to multiply it by itself. So x squared, the exponent of 2, tells you to square the number. So in the example here, 7 squared, we do 7 times 7 and get 49. Let's practice. 15 squared, again, that exponent of 2 says it is 15 times 15. So 15 squared equals 225. So the square of 15 is 225. Number 14, again, we're squaring, we're just multiplying it by itself. 14 times 14. That equals 196. So the square of 14 is 196. To find the square root of a number, we're doing the exact opposite. We're trying to find out what two numbers multiply to equal that number. So if you know your multiplication facts well, some square roots are going to be very easy to find using method 1. Method 1, you have to know it. So to find the square root of 36, if you know in your head that 6 times 6 equals 36, you already know that the square root of 36 equals 6. If you don't know your doubles or your multiplication facts, you can use prime factorization to find the square root of a number. So we're, again, breaking it down. 36 can be broken down into the prime number of 2 and 18. 18 can be broken down into 2 and 9, and then 9 into 3 and 3. We use our prime numbers to break it up into two sets of parentheses, where the multiplication inside is the same. So I have 2 2s and 2 3s. So in each parentheses, I'm going to have to put a 2 and a 3. And then I simply multiply what is inside those parentheses, 2 times 3, and that 2 times 3 is 6. So that's how I find the square root of 36. So let's use prime factorization to find the square root of 81. I know that 3 can go into 81 because 8 plus 1 is 9, which is a multiple of 3. So 81 divided by 3, I'm not sure, so I'm going to do long division to check. 3 goes into 81 or into 8 twice. That's 6, 2, 1, and 7. So 3 times 27 is 81. I know 27 is 3 and 9. I'm not going to forget to circle my prime factors here. And 9 times 9 is 3. 9 is 3 times 3. So 81 equals 3 times 3 times 3 times 3. This is quite simple because it's all the same number, so I'm just going to put a 3 on each line. 3 times 3 is, I'm actually breaking this down and taking away the extra and using my exponent of 2 to show that that happens twice. 3 times 3 is 9. So 89 squared is 81. So the square root of 81 is 9. Let's try with 256. I'm going to erase a little bit up here so we have room to do the factor tree. All right, 256. 256 can be divided by 2. I know that because it's even. So that will be 128. Again, another 2 can go in here. 2 times 64 is 128. 64 is 2 times 32. 32 is 2 times 16. 16 is 8 times 2. 4 times 2. And 2 times 2. We got a lot of 2's here. So 256 is the same as 2 times 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 2. So I want to break that up into 2 separate parentheses with the exact same thing in it. So each parentheses will have 4 2's in it. And I'm going to multiply what's inside one of the parentheses to find what the square root of 256 is. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So the square root of 256 equals 16.